The Big Bang. Our universe is a vast and mysterious place, filled with billions upon billions of stars, galaxies, and planets. But have you ever stopped to wonder where it all came from? How did this incredible tapestry of cosmic wonders come to be? The answer, my friends, lies in an event of unimaginable power and grandeur, the Big Bang. Imagine, if you will, a point smaller than the tiniest atom, containing all the matter and energy of the universe as we know it. This point, incredibly dense and hot, suddenly began to expand rapidly, an event scientists call the Big Bang. This expansion, which began approximately 13.8 billion years ago, continues to this day, stretching the very fabric of space-time. As the universe expanded and cooled, energy began to transform into particles, the building blocks of matter. These particles in turn came together to form the first atoms, primarily hydrogen and helium, the lightest elements in the universe. These simple atoms would eventually serve as the raw materials for everything we see around us today, from the stars in the sky to the very ground beneath our feet. It is a truly awe-inspiring thought that everything we know and love originated from this single, momentous event. The Big Bang is not just a theory, it is supported by a wealth of scientific evidence, including the observed expansion of the universe, the cosmic microwave background radiation, and the abundance of light elements. These lines of evidence converge to paint a clear picture of a universe born from a cataclysmic explosion of energy and matter. In the aftermath of the Big Bang, the universe was a vast expanse of hot, glowing gas, primarily hydrogen and helium. Over millions of years, this gas began to cool and clump together under the influence of gravity. As these clumps grew larger and denser, their gravitational pull intensified, drawing in even more gas and dust. Eventually, these massive clouds of gas and dust reached a critical point where the pressure and temperature at their cores became so intense that nuclear fusion ignited. In this process, hydrogen atoms were fused together to form helium, releasing enormous amounts of energy in the form of light and heat. Thus, the first stars were born, illuminating the early universe with their brilliant light. These early stars were massive and short-lived, burning through their nuclear fuel at an incredible rate. When these stars eventually exhausted their fuel, they exploded as powerful supernovae, scattering their newly formed elements, such as carbon, oxygen, and iron, into the surrounding space. These heavier elements, forged in the fiery hearts of stars, would become the building blocks for future generations of stars, planets, and even life itself. As more stars formed, they began to cluster together under the influence of gravity, forming vast collections of billions or even trillions of stars known as galaxies. Our own galaxy, the Milky Way, is a barred spiral galaxy containing over 100 billion stars, a tiny island of light in the vast cosmic ocean. About 4.6 billion years ago, in a relatively quiet arm of the Milky Way galaxy, a giant molecular cloud of gas and dust began to collapse under its own gravity. This cloud, likely remnants of a previous supernova explosion, contained all the elements necessary to create our solar system. As the cloud continued to contract, it began to spin, forming a flattened disk of material surrounding a central protostar, the infant Sun. Within this swirling disk, dust grains collided and stuck together, gradually growing larger over time. These growing clumps of rock and ice attracted more and more material, eventually forming planetesimals, the building blocks of planets. In the inner, hotter regions of the disk, rocky planetesimals collided and coalesced to form the terrestrial planets, Mercury, Venus, Earth, and Mars. These planets are relatively small and dense, composed primarily of rock and metal. In the outer, colder regions of the disk, where water ice could exist, gas giants like Jupiter and Saturn formed. These massive planets, with their powerful gravitational pull, swept up vast amounts of gas and dust, becoming the behemoths we see today. Further out, in the icy realms beyond the gas giants, Uranus and Neptune formed. These ice giants, while smaller than Jupiter and Saturn, are still significantly larger than the terrestrial planets and possess a unique composition of ices, rock, and gas. Our home planet, Earth, formed approximately 4.54 billion years ago, coalescing from the swirling disk of dust and gas that surrounded the young sun. In the early days of Earth's existence, it was a hot and violent place, bombarded by asteroids and comets left over from the formation of the solar system. One particularly significant impact, known as the Giant Impact Hypothesis, is thought to have occurred when a Mars-sized object collided with the young Earth. The debris from this colossal collision is believed to have coalesced to form our moon, a celestial companion that has played a crucial role in stabilizing Earth's climate and tides. As Earth cooled and stabilized, volcanoes erupted, releasing gases from the planet's interior, including water vapor, carbon dioxide, and nitrogen. These gases formed Earth's early atmosphere, while the condensing water vapor collected in basins to form the first oceans. The early Earth's atmosphere was very different from the one we breathe today, lacking oxygen and rich in greenhouse gases. However, this early atmosphere played a crucial role in trapping heat from the sun, allowing liquid water to exist on Earth's surface, a key ingredient for the emergence of life. Section 5. The spark of life. Life begins in Earth's oceans. The exact origins of life on Earth remain one of science's greatest mysteries. However, the prevailing scientific theory suggests that life arose from non-living matter through a process called abiogenesis. This process, though not fully understood, is thought to have occurred in a series of steps, beginning with the formation of simple organic molecules from inorganic matter. These organic molecules, the building blocks of life, likely formed in Earth's early oceans, a primordial soup rich in dissolved minerals and organic compounds. Energy from lightning strikes, volcanic eruptions, and the sun's ultraviolet radiation provided the spark needed to drive chemical reactions that assembled these molecules into more complex structures. Over time, these complex structures self-assembled into even larger, more intricate systems, eventually forming the first self-replicating molecules, the precursors to DNA and RNA. These molecules, capable of storing and transmitting genetic information, marked a crucial turning point in the journey from non-living matter to life. The first life forms on Earth were single-celled prokaryotes, simple organisms lacking a nucleus or other membrane-bound organelles. These early life forms thrived in the harsh conditions of the early Earth, obtaining energy from chemical reactions in the oceans or through photosynthesis, a process that harnesses sunlight to convert carbon dioxide and water into energy. Section 6. From the primordial soup to land, life climbs out of the ocean. For billions of years, life on Earth was confined to the oceans, evolving and diversifying in the planet's vast aquatic realms. However, about 3.5 billion years ago, a remarkable event occurred. Photosynthesis evolved in certain types of bacteria, releasing oxygen as a byproduct. This oxygen, initially toxic to many early life forms, gradually accumulated in the atmosphere, eventually reaching levels that allowed for the evolution of aerobic respiration, a more efficient way to obtain energy from food. This metabolic innovation paved the way for the evolution of larger, more complex organisms. As oxygen levels rose, a protective layer of ozone formed in the upper atmosphere, shielding Earth's surface from harmful ultraviolet radiation. This shield made it possible for life to venture out of the oceans and onto land, opening up vast new habitats for colonization. The first organisms to colonize land were plants, followed by invertebrates such as insects and arthropods. These early pioneers faced numerous challenges on land, including the need to develop structural support, prevent water loss, and reproduce outside of an aquatic environment. However, over millions of years, they adapted and thrived, paving the way for the evolution of vertebrates, animals with backbones, on land. Section 7. A walk through time, the evolution of mammals. The story of mammals is one of adaptation, resilience, and remarkable diversification. Evolving from a group of reptiles called synapsids about 225 million years ago, mammals faced numerous challenges and opportunities as they navigated a world dominated by dinosaurs. Early mammals were small, nocturnal creatures, likely relying on their keen senses of smell, hearing, and touch to survive in a world ruled by larger, more powerful reptiles. These early mammals possessed several key features that set them apart from their reptilian ancestors, such as hair or fur for insulation, mammary glands for nourishing their young with milk, and a more efficient four-chambered heart. The extinction of the dinosaurs about 66 million years ago, likely caused by an asteroid impact, marked a turning point for mammals. With their reptilian competitors out of the picture, mammals experienced a dramatic adaptive radiation, evolving into a dazzling array of shapes, sizes, and ecological niches. From the tiny bumblebee bat weighing less than a dime to the massive blue whale, the largest animal to have ever lived, mammals have colonized every continent and habitat on Earth, showcasing the incredible power of evolution to shape life's diversity. Section 8. The Dawn of Humanity, the Rise of Hominids. The story of humanity is a relatively recent chapter in the grand epic of life on Earth. Our lineage diverged from that of our closest living relatives, the chimpanzees, about 6 to 8 million years ago, marking the beginning of the hominid lineage, the group that includes modern humans and our extinct ancestors. Early hominids, such as Sahelanthropus and Ardipithecus, were ape-like creatures that inhabited the forests of Africa. These early ancestors possessed a mixture of ape-like and human-like traits, including small brains, long arms for climbing, and the ability to walk upright on two legs, a defining characteristic of hominids. As time progressed, hominids continued to evolve, developing larger brains, more sophisticated tools, and complex social structures. The genus Homo, to which modern humans belong, emerged in Africa about 2.8 million years ago, marked by the appearance of Homo habilis, known for its use of simple stone tools. Homo erectus, a more advanced hominid with a larger brain and a more upright posture, emerged about 1.9 million years ago and was the first hominid to migrate out of Africa, spreading to Asia and Europe. These early explorers were followed by other Homo species, including Homo neanderthalensis, our closest extinct relatives, who inhabited Europe and parts of Asia until about 40,000 years ago. Section 9. The Future of Creation, our continuing story. Our own species, Homo sapiens, emerged in Africa about 300,000 years ago. Possessing a remarkable capacity for language, culture, and innovation, Homo sapiens quickly rose to become the dominant species on Earth. From the development of agriculture and the rise of civilizations to the scientific revolution and the digital age, humans have left an indelible mark on the planet, shaping the world around us in profound ways. However, our journey is far from over. As we continue to explore the universe, unravel the mysteries of life, and grapple with the challenges facing our planet, the story of creation continues to unfold. The future of life on Earth, and indeed the universe itself, remains unwritten. The choices we make today will determine the course of our planet's future and the legacy we leave behind for generations to come. As we stand at the precipice of new discoveries and challenges, let us remember the interconnectedness of all living things and strive to be responsible stewards of this pale blue dot we call home. For we are all part of this grand cosmic story, a story that began with a bang and continues to unfold with each passing moment.